Okay, so yeah, so this is November going on right now, right? So how is your preparation going till now? How are you approaching? I mean, how are you planning to do it? Are you appearing for test series or something? Anyone?
Yes, sir.
Okay, good. That is good. I would recommend everyone to appear for test series. That is important. Keep practicing more. Solve previous year questions. So this session should be like net practice to you people. It won't be more than 30 minutes, I guess. So every week you can just come in and you can just solve and see where you stand right now. So that would be a good practice. I think. So let us start today's sum. Okay, so it's not possible for me maybe to know everyone's background, but I'm hoping that everybody are studying. They're studying and preparing well. They're working hard. So let us start the first sum that I would be giving you. Okay, okay, I need to share my screen, right? You can see my screen right now, right? Is my screen visible to everyone?
Yes, sir. But
Okay.
yes, sir.
So this would be your first sum for today. Okay. So I will give you 3 minutes time and let's see what you get. হ্যালো বাবা, আমার ক্লাস চলছে, আমি পরে কথা বলছি। So 3 minutes time is up actually. So how many of you are with answers? Anybody with the answer yet? Yes, Akash Gupta, what is your answer? Akash Gupta is saying option D. Okay, anybody else? Just a minute, just a minute. হ্যালো বাবা, আমার ক্লাস চলছে, আমি তুমি বললাম না 7টা থেকে ক্লাস থাকে আমার। তুমি পরে ফোন করো না, পরে দেখা যাবে, পরে দেখছি, রাখো। Yes, anybody else with the answer other than Akash? Navkirti, what is your
Sir,
status?
I tried solving by integrating for 0 to t to 1 and by taking the slope of that from
Why,
t to 2t.
why
But
integrating? I mean, what is the need for integration in this sum? What is the need for integration in this sum?
yes, sir, in this way I'm just
See, integration gives you the area under the curve,
area.
right?
Yes, sir. Yes, sir.
So you are not you are only asked how would you realize this function. You are not asked to find the area under this curve.
Yes, sir. Yes, sir. I did it wrong.
Okay.
Option A.
Option A. BS Gayatri is saying option A. Anybody else? Don't be shy. Please speak up, because or else the entire the initiative of live session goes away. Anu is saying it is option A. Okay. So Akash Gupta has said it is option D, and Gayatri said it is option A, and Anu said it is option A. Anybody else? Prashant? Prashant, what are you getting? Please, if you can, write on the chat window, or you can just unmute yourself and say. Prashant, can you hear me? Option A, okay. Anybody else? Okay. So yeah, the correct option is A. It is correct. So let us go through the steps how to do this. So let us go step by step. Okay. So first, let us focus on this part where we have a pulse from 0 to t. Okay. To realize this pulse, what we need to do? Say we have a unit step function ut. So we know the definition of ut is from 0 to infinity it would be 1, and for t less than 0 it would be 0. So the function ut would look somewhat like this. So if I want something like this, what we need to do is we need to shift this function, and you have to add these two functions. So what is this function? This is shifted version of u of t by a amount t. So you shift u by amount t and then invert it. So you get minus of u t minus t is a function which is shown in this slide. So if we add these two, say this part gets subtracted and becomes 0. So you're only left with this pulse. So from 0 to 2 it would be 1. Okay, a unit pulse you get. So from the function from 0 to 2, the 0 to t has been realized now. So what we are left with is this ramp function, this slope, and this constant part. So how do you realize this? So after having realized this pulse, this square pulse, let us forget about it. This rectangular pulse, let's forget about it and focus on this slope part, this linearly rising part. Okay, how to do that? So what is the equation for this line? Anybody from the audience? What would be the equation for this line?
T into U of T.
T t into u of t would pass to 0, right?
Sir?
T into u of t would pass to 0. So it is not passing through 0. It is not passing through origin.
A t into u of t minus
T minus
capital T.
t minus capital T. So in that case, what is the slope of the line? Slope of this ramp function?
Mm, It's t.
So the function that you are saying t minus capital T, in that case, the slope is unity. What is the slope in this case? The slope of this line. What is the slope of this line?
Sir, slope will be 1 over t.
Correct. Absolutely. And what is the intersection of this line with the y-axis? So if I extend this line, what would be the intersection with the y-axis?
At 1
At minus 1, right?
minus 1, yes, sir.
Correct. So so if we plot this, if we extend this line and extend it in the negative direction of y-axis, you find that it will intersect at minus 1 and it has a slope of 1 by t. So if we write the equation for this straight line, it would be t minus capital T divided by capital T, right? You agree with me on this point?
Okay, sir.
Right. So now this part of this ramp function, you do not want this part because you do not want the rectangular pulse that you have obtained to be affected by this part of the function of this ramp function. So what you do, you multiply this with a unit step function which is shifted by amount t. So below, when t is less than capital T, it would be 0. So if you multiply these two functions, what you are going to get is a linearly rising function like this, which is 0 from 0 to capital T, and it linearly rise from t to infinity. From capital T to infinity, it would be linearly rising with a slope 1 by t, correct?
Mr. Basak, Namrata here. Can you please repeat t minus capital T by 2, please? I'm sorry, I think I did not catch it.
Okay, so if we can you write the equation for this straight line that you have? Did you understand why I how I said that if I extend this straight line, it would
Yeah.
intersect at minus 1? Do you get that point?
Yes, I got that point. Yes.
So equation for the line which has a which intersects the y-axis at minus 1 and has a slope 1 by t. What would be the equation for that line?
1 by t.
1 by t is the slope of the line. So
Okay.
you are given two information. So the slope of the line is 1 by t and it
Okay.
intersects the y-axis at minus 1. So what would be the equation of the line?
So it would be 1 minus t by t.
1 minus t matlab you are talking about the small t, right? So 1 minus t matlab the slope is negative. That is not good.
Yes.
Slope is positive, right?
Oh, okay.
So you break this. So you break this into like partial fraction breaking, break it. So what it becomes is t by capital T, small t by
Minus
capital T
1.
minus 1.
Yes.
So small t by capital T means 1 by t is your slope, right?
Okay, yeah, correct.
So minus 1,
Got it.
when t equal to 0, the y becomes minus 1. So you get minus 1.
Yes.
Got it?
Yes,
Okay.
yes.
So you multiply that with u of t minus capital T.
Okay.
So that this portion vanishes. We don't want this portion because this portion would affect the red part that you have obtained.
Okay.
Right.
Thank
So
you.
we don't want this portion. So we have multiplied this with this function in order to get this function. Okay. So now the problem is from t to infinity, this function would keep on rising with a slope 1 by t. Right. You agree with me on this point?
Yes, sir.
Okay. So what is our objective now? We want this line to be straight after 2t, right? After 2t, you don't want it to be rising. You want it to be straight and you want the magnitude to be 1 and remain at 1 from 2t to infinity, right? Correct? This function, this is what you have to realize. So what you see, from 2t we want the function to be constant at 1. This is what we want. Did you get the point?
Yes, sir.
So how would you do that? So if you have a linearly rising function and you want to cancel that out and you want that to be fixed at some value, what do you need? Namrata, what would you need to do cancel this out after
Multiply
multiply with
constant u of t minus t.
so if you multiply with this multiply with u of t minus 2t, so how would the function look like? You will only have this portion. Right? You are getting my point. You said you would be multiplying by u t minus 2t. U to t minus 2t means there is a unit step from starting from 2t to infinity. That means you are only getting this portion. So that won't be the current, right? How to cancel a linearly rising function?
So to cancel out from 2t to 3t, we need something in the opposite direction of this slope, like this going
Absolutely,
up.
absolutely. Right, correct. You need another linearly decreasing function which would cancel it. Say if you have y of minus t, you want to cancel it. So you need to have plus t, right? So minus t plus t becomes 0, it remains fixed at 0. So if you want to give a constant values, then 1 plus t. So minus of t plus 1 plus t, t and minus t cancels out, you get fixed at 1. So what we need to do now is we need to find another function which has a negative slope, not a positive slope, but a negative slope, so that this portion get cancelled out. So now we have seen that, so if you are implementing using this function, so at 2t, you are already getting 1. You are already getting 1. So I want the value at 2t to be 1. So the negative slope that I'm talking about, the function that I'm talking about, which need to have a negative slope, must have a value 0 at 2t, right? So it should intersect the t-axis at 2t. Did you understand what I'm saying? Did you understand what I'm saying?
So can you repeat this point?
Yeah, see, so if you are adding this function and the other function I'm talking about, see, in this function, you have already got a value 1 at 2t, right?
Yes, sir.
So at 2t, you have already got a value 1. Now you want to add something to this function so that this becomes constant at 1. So at 2t, as the function's value is 1, so the value of the other function which I am adding to this function has to have a value 0 at this point.
Yes, sir, so that it doesn't cancel out the value at 2.
Correct, absolutely, right. So if we do that, so what information we have? So its slope should be minus of 1 by t and it should intersect the t-axis at 2t, right? So this would be the nature of the function that I'm talking about. Okay. So what informations you have now? So you see it is intersecting the y-axis at 2. It has a slope minus of 1 by t. So if you write the equation for the straight line, you would have a equation which is minus of t minus 2t divided by t. Okay. Everybody is agreeing to me up to this point?
Yes, sir.
Okay. So now again, just like the previous case, we do not need this function before 2t, right? We do not need this part of the function. We just need the function from 2t to infinity, right? Because we need to cancel out the effect of this positive slope from 2t. Getting my point?
Yes, sir.
So before 2t, we do not need this function because this would again affect this linearly rising function. We do not need that. So we do not want that rather. So what we do, we multiply this with u of t minus 2t so that the function becomes like this as shown on the slide. Getting my point?
Yes, sir.
Okay. So now, so this is the same thing that I've already explained to you. So if you add these two functions, see it is existing from 2t and it is a slope opposite to that of this slope, and this function has a slope 1 by t from t to 2t, and value of this function during this period t to 2t is 0. So if you add these two function, what you are going to get is this linearly rising part and then a constant part, right?
Yes, sir. Because it will shift it by 45 degree, na.
45 degree, where do you get degree over here?
So just a random means I'm just क्या कहते हैं उसको generalizing it because the
Gen-
slope is the angle, the slope is going in positive direction.
Mhm.
Negative slope must be from the same angle only, na.
Right. Okay, you are talking about the slope. You're talking about this
The
slope.
angle of the slope.
Okay. Okay, right. So you understand how I have realized this part of the function?
Yes, sir.
Okay. So now this part you have already got, and now you have realized the rising part and the constant part. So you now add all this that you have got. So ut minus u of t minus capital T. There is a red part which I have shown, and this portion is the linearly rising part and then a constant part. So the correct option is A. Okay, you got the point. Everybody is clear with the concept.
Yes, sir. What mistake I did was I consider as a continuous slope with a change from T to 2T. That was my mistake.
Okay, note it down. Note your mistakes down. That is very important. Okay.
Yes, sir.
So if anybody else has any doubt or if it is clear to everyone? Navkirti, is it clear to you?
Yes, sir.
Okay. Namrata?
Yes.
Prashant? Okay. Anu has written the correct answer. Gayatri is also correct. Okay. So, Harsh. Harsh, are you?
Yes,
Yes.
sir.
Yeah, was the explanation clear to you?
Yes, sir.
Okay. Now let us move to the next sum. This would be the last sum, maybe. Okay. So, uh, so xz is the z transform of a causal signal xn. You need to find the values of. Okay, there is a problem over here, I think. Just give me a minute. I'm unsharing my EA for a minute. Just give me a minute. Okay, what was the question? Okay, it's question number 34. Okay. Okay. So this is question number 34. You can see question number 34. This is the question. Xz equal to 1 divided by 1 minus z whole to the power minus 3. This is the question. Can you see the question?
Yes, sir.
Okay, so these are the options and this is the question that has been given to you. I will give you another 3 minutes to solve it and tell me after you have solved it. I mean, after 3 minutes, I will be asking you. Anybody with the answer yet?
No, sir, I didn't revise that transform yet.
Sometimes you don't need to revise. These questions do not need revision. You can just use some logic to, if you don't want to use property, you can use some logic to find the answer out.
So the option B, 0 and 1.
Okay, who is that?
I'm Akash.
Okay. Okay, 3 minutes time is up. Anybody else with the answer?
I'm not sure, but I think it's D. It's been so while.
Yeah, it is. You are
I'm really
telling
not
it
sure.
is D for dog.
Yeah,
Okay.
I'm really not sure. I have
Okay.
no
Okay.
logic to
It's
apply here,
okay. It's
but
okay.
I just
No problem. It's
did
okay.
few things.
Anu, what's your answer? Prashant, B. Anu is saying B. Good. Prashant, what's your answer? Okay. Prashant, you are a bachelor student. What is your background? BE. Okay. You are from BE. I mean, most of the colleges offer BTech. I mean, BE. Which college is this? Okay. Okay, so what I would do is I would show you two ways of doing it. Okay, I would show you two ways of doing it so that you know. So one way is using property. For that, you have to keep a lot of things in mind. So u of n, the z transform of u of n is 1 divided by 1 minus z whole to the power minus 1. So if you do time scaling n by say a, so it becomes z whole to the power minus of m. If it is instead of 3, if you have m, then it would be z whole to the power minus of m. Okay, and ROC changes by this. If it is 1, it is whole to the power 1 by m. Okay, so in that case, you have, if you take inverse z transform, you have x of n is equal to u of n by 3. Now u of n by 3, this entire argument inside this third bracket, you see, it has to be an integer. So n has to be a multiple of 3 for xn to be non-zero. Okay, do you get my point?
Yes, sir.
So u of n by 3 has to be an integer for un to be non-zero, or else it would be 0 because it is a discrete signal. It would have values only at integer values, right? So n has to be a multiple of 3. So in order to get xn to be non-zero, so you see 2 is not a multiple of 3, so you have x of 2 equal to 0, and 3 is of course a multiple of 3, so it is 1 because u of this entire argument would become 1 if n equal to 3. In that case, x of 3 would be 1. So the correct option is B. In case you don't remember all these properties, you have another way of doing it. So what I have done is, so just like Navkirti said, I have not revised. So you don't need to revise, just know the basic definition of Z transform. Okay. So you see, you just simplify this. So what you get is Z cube divided by Z cube minus 1. Now divide this. Z cube minus 1, you divide Z cube by Z cube minus 1. So you get the quotient something like this. Okay, you know the division method. So you multiply with 1, you get z cube minus 1, and then you subtract this 2, you get 1, and then if you want to remove this part, you multiply with z to the minus 3. In this way it goes on. So what we can write now, x of z can be written as summation of n equal to minus infinity to infinity x of n z whole to the minus n. This is the definition of z transform, right? This much you know.
Yes, sir. This definition.
This definition is enough for you to solve the sum. So if you know this part, so this I have expanded this. So what does this mean? X of 0, because it is a causal system, so a causal signal, so it exists only from n equal to 0. So x of 0 plus x of 1 z to the power minus 1 plus x of 2 z to the power minus 2, and so on. And what you have got is x of z that I have shown in the previous slide. Okay, x of z, if you divide, you get 1 plus z whole to the power minus 3 plus z whole to the power minus 6 and so on. So you see the coefficient of z whole to the power minus 2 is x of 2 and that is 0. So there is no coefficient. You can see it from this expression. So x of 2 would be 0 and x of 3 is the coefficient of z whole to the power minus 3 and that is 1 over here. You can see this. So x of 3 is 1. From here also you can say it is option B. So these are the two ways by which you can solve the sum. Okay, is it clear? Is the solution clear to you?
Yes, sir.
Okay, is it clear to everyone?
Yes, sir.
Okay, Akash, how did you do it? Did the first method or the second one?
Sir, I used the second one because
Okay.
revision is also needed for the first one.
Okay, okay, okay. Okay, so I would end the session now. So you would be meeting again on Friday. I would be giving you again another two sums. Okay, so that would be the way forward. Okay, enjoy your weekend. Bye bye. Good night.
Thank you, sir. Same to you.
Thank you.
Thank you.